All right, so corresponding parts of similar figures. So when we talked about dilations the other day, there were two important things that we talked about. One was that the angle measures are congruent. And who remembers the second one? Angles are congruent and
Sides are proportional.
Sides are proportional. Okay, that's going to be important when we're talking about similar figures. A dilation is just a similar figure. Okay, it's not exactly the same because it got bigger or smaller. It's going to be the same here. So you have to have congruent angles and you have to have side lengths that are proportional. If you don't have those two things, the figures are not similar. Okay, so let's look at an example. You're going to have to draw. So here we have two figures, A, B, C, D. I'll give you a second to draw. And E, F, G, H. And before we even look at anything, I want to make sure we know what all those marks mean. Do we know what this is? 90-degree angle. So if you see a box that tells you it's a 90-degree angle, what are these marks? Do you know what they're called, first of all? It tells you all the sides are congruent, but do you know what those marks are called? They're called tick marks. Okay? These ones here are called arc marks, and it tells you that F and H are congruent because they both have two arcs, and it tells you E and G are congruent because they both have one mark. Are we okay with that? Okay, so the first thing that we need to show is that all angles are congruent in both figures. Are all the angles in this figure congruent to all the angles in this figure? No. These are all 90 degrees. I have no idea what those are, but I know they're not 90 degrees because they would be marked with a right angle if they were. So right away, we can say these figures are not similar because you have to show all angles are congruent. So the figures are not similar because the angles are not congruent. Right away, I can say those angles are not congruent, so I'm not doing any other work. Those figures are not similar. Are we okay with that? Okay, let's look at another one. My figure is not 100% to scale, but we're going to use the information that we see to help us prove whether or not it's similar. So step one is to show all, yeah. It's just an arc, like one arc. Yeah, this is just an arc here, not a box, 90-degree box. So step one is to show all the angles are congruent. Now up here, all of these were 90 degrees, which means all of these would have to be 90 degrees. They don't all have to be the same measure, but one in one figure has to be the same as another in another figure. Okay, so for instance, angle L. Is there an angle that matches angle L in my second figure?
Yeah.
T, right? So I know angle L is congruent to angle T based off the information from the figure. Is there an angle that matches M? P, right? Angle M is congruent to angle P. Now, N and O don't have any marks. Do we know if N and O are congruent?
Yes,
Yes? Why?
because if L and M are congruent, then that means that the other one's going to be congruent because it always equals 180 degrees.
Perfect. Okay, that's called the third angles theorem. So what it's saying is if you have two angles in one triangle congruent to two angles in another triangle, the third angles have to be congruent. All of those angles will always equal 180 degrees. So if those add up to something, whatever's left over will be the same for N and O. So I can say N is congruent to O. Okay, so all the angles in that figure are congruent. Everyone okay with angles? Okay, which means we have to keep going. In the first one, we knew the angles weren't congruent. We could stop. What's the second piece of information that's completely important that we have to solve? Sides are proportional, which means they have the same scale factor. Okay, now here's how we're going to do this. So let's look at LM, for instance. LM. What do you think LM would be proportional to? And again, mine's not drawn to scale, but what would LM be proportional to in this figure over here? TP, right? Because L and T are congruent, and M and P have to be congruent. So that would be proportional to TP. Are you okay with that? What's the measure of LM? 8. And what's the measure of TP? Okay, and 8 over 6 reduces to? 4 over 3. So if I set up all my proportions and I get 4 over 3 for every single side, it tells you that they're proportional. So let's go to the next side. Let's do MN. What would MN be proportional to? PO. I started with the single arc and I went to the one that has no arc. So single arc to no arc is PO. So MN is 6. PO is 4.5. Do we remember how we fixed that decimal issue? Multiply by 10. So that's giving me 60 over 45. What number goes into 60 and 45? It's going to be 4 over 3. 15 goes into both. 15 goes into 60 4 times. 15 goes into 45 3 times. See if you can set up the last proportion. What two sides are the last side that we're thinking of would be proportional. So take a second with your group and see if you can set up the last proportion. Who thinks they have the last proportion? LN to TO, I will take it. If you switch the letters around, that's okay. So if you did N to L and O to T, that's fine. What's LN? 12. And TO is 9, which reduces to 4 over 3. So all the angles are congruent and all the sides are proportional. That means those two triangles are similar. I'm going to write a similarity statement. So if I say triangle LNM, what triangle is similar to LNM? TOP. Okay, so I did double arc to nothing to one arc. So I go double arc to nothing to one arc. Remember, our letters need to be in the same order. We talked about that on the first day of dilations. So if you're asked to prove something similar, you're going to check all the angles. Do the angles first because it's the easiest. If the angles don't work, then you can stop. If the angles do work, then you need to check that all the sides are proportional. As soon as you find one, though, that's not proportional, you can stop. Okay? Questions on similar figures? All right, we're going to do a little more solving. And then we're going to solve for the variable. If you're not sure what something says, please ask. And as you're finishing up, I'm going to explain. In order to solve for the variable, we need to know that the figures are similar, which we do based on like the directions. Okay, so these are already similar. In order to solve, we are going to set up a proportion. Okay, so we're going to set up what sides would be proportional. Now, the easiest way to do that is go, let's go small triangle to big triangle so that we're consistent. Do you see two different triangles in there? Yeah? You should see this small one, and then you should see the big one, right? Okay. So for this type of problem, let's start with 22 because that's my small. What would 22 be proportional to in the big triangle? So here's the small one. What would it be proportional to in the big triangle? 14x minus 11. Okay, if those triangles were separated, that's what we would compare if we were looking for scale factor. Here we're solving. So small triangle to big triangle. We're going to do the same on the other side. Small triangle to big triangle. So small to big, small to big. Can you solve that proportion? Yeah? The hardest part is setting it up. So if we can just practice setting it up, the solving should not be difficult. Now you'll notice that you have 24 over 156. We probably can simplify that a little bit so we don't have to deal with such a big number. Does 24 go into 156? No. Is there a number that we can simplify that by, do you think? 4?
3.
4 goes into both. So I'm going to just simplify it now so I don't have to worry about it later. 4 goes into 24 6 times. 4 goes into 156 39 times. So now my numbers are a little smaller. If we cross multiply 39 times 22 is 858. And that equals what? (14 times 6), which is 84x, and 6 times negative 11, which is negative 66. How do I get x by itself? Add 66. 266 plus 858. I'm getting 924 equals 84x. And what do you get when you divide by 84? X equals 11. Yeah.
Why did you make those two fractions equal to each other? The 22 over 14x minus 11.
Because you have to set up a proportion. The side lengths have to be proportional for it to be a similar figure, so we're setting up a proportion so we can solve. I could have used this piece here, this 14 and 91, instead of the 24 and 156, and you're going to get the same answer. I just like to use the same information to keep it less confusing. But information from the small triangle to information in the big triangle. If we're looking at a different figure, information in the small figure to information in the big figure is the best way to keep it consistent. Okay? This we're going to practice for a couple days. Are we okay with that? Yeah? Okay, let's look at another one. We already know they're similar, so we need to set up a proportion in order to solve for x. So we're going to go small figure to big figure. So where do we want to start?
21 over 91.
Okay. Can someone tell me why Micah chose 21 over 91? Because you know that they're similar because of the tick marks, right? So 21 over 91. And then I'm left with 39, and that should match up with the negative 11 plus 15x. Okay, I want you to take a second, either by yourself or with your group, and solve that proportion and see what you get. When you solved, did you get x equals 12?
Yes.
Yeah? Okay. I'm going to give you one more, and I want to see if you can set up the proportion. I don't want you to actually solve it till we make sure your proportion's correct. Okay? This is always everyone's favorite picture to draw. I'm kidding. So it's just two triangles that are next to each other. Okay, so based on the information that you have, all I want you to do is set up the proportion. Don't solve it yet, just set up the proportion. Yeah. It's an R. Okay, so you're setting up a proportion. Somebody who has not helped me today. What is your proportion? $10x over 44. Okay, you could have done 44 over 10x. And? Okay, so if we're going to go 10x over 44, we have to start at this triangle and go 55 over 56. If your proportion is completely flipped, you're fine. Okay, I would have probably gone small to big, but if you go big to small, that's okay. You just have to be consistent. So 10x over 44, 55 over 56, or 44 over 10x, 56 over 55. Okay, just make sure you're consistent. All right, let's solve that. So 44 times 55 is 2420 equals 560x. What happens? Who plugged that into their calculator? Can you simplify where? Yep. Did anyone plug 2420 divided by 560 in their calculator?
It's 4.4.
You get a decimal. All right, so let's not have a decimal and just reduce because we need to practice reducing. How can I reduce that? What's the first thing I can do?
10.
You can cross out the zeros. It is the only number you're allowed to cross out because it's like dividing by 10. So now I have 242 over 56. Well, what are some numbers that go into 56? Let's start there. 7?
4.
So 7, we know 7 goes in, so does 7 go into 242? No. What else goes, what 7 times what gives you 56? 8. So does 8 go into 242? Nope. Okay, so you 7, 8. What else goes into 56?
4.
4. Okay, does 4 go into 242?
Yes.
Nope.
2.
It does? 242 divided by 4 is 60.5. 2 goes into it. Okay, so 242 divided by 2 is 121. And 56 divided by 2 is 28. I know that the only factors of 121 are 11. I know 11 doesn't go into 28, so that's going to be my answer.
Can we do this as a decimal as well?
If you do it as a decimal, it is not wrong. I will probably mark it right and ask you to round to the nearest tenth. However, based on our test, we need to know how to reduce fractions. So that's why I'm practicing that with you guys here. Okay. All right, last thing I want to look at. It's the last problem, so try to just squeeze it if you can. So scale factor is a ratio. When we're talking about scale factor, what are we looking at? What part of our figure? Those side links. You should write that down. Scale factor means you're looking at side links. You do not care what the angles are. So this 125 degrees down here is just there to throw you off. You don't care what that is. You are only looking at side links when we're talking about scale factor. Now it tells you in the directions. You're going to go from the big, or from RSTU to LMNO, which means RSTU is on top, LMNO is on the bottom. So is there a side length in both figures, both parallelograms, that match up? So you're saying ST? What does ST match to? MN. Okay, so ST is 3, MN is 2.4. That's not going to work for us. How do we fix it? Multiply by 10. So it's 30 over 24. And what goes into 30 and 24? Higher? 6. 6 goes into 30 5 times. 6 goes into 24 4 times. So my scale factor is 5/4.